Ever wondered why a pencil appears bent when you dip it halfway into a glass of water? Or why stars twinkle? The answer lies in a fascinating physics concept known as refraction. Refraction, at its simplest, is the bending of light. It occurs when light passes from one medium to another, and the speed at which the light travels changes. Picture walking from a concrete path onto a sandy beach. Your pace slows, you adjust your stride, and your path may even change slightly. That's similar to what happens to light during refraction. When light moves from a medium like air into a denser medium like water, it slows down and bends towards what we call the normal line, an imaginary straight line at a 90-degree angle to the surface of the medium. Conversely, when light leaves a denser medium and enters a less dense one, it speeds up and bends away from the normal line. This bending is what causes the pencil in water to appear broken or bent. Now, refraction isn't a free-for-all. It follows specific laws, known as the laws of refraction. The first law states that the incident ray, the refracted ray, and the normal line at the point of incidence all lie on the same plane. The second law, also known as Snell's law, quantifies refraction, providing a mathematical relationship between the angles of incidence and refraction, and the refractive indices of the two media. Understanding refraction also introduces us to a few important terms. The angle of incidence is the angle between the incident ray and the normal line, while the angle of refraction is the angle between the refracted ray and the normal line. The refractive index, meanwhile, is a measure of how much a medium can bend light. There's also a fascinating phenomenon called the critical angle. When light moves from a denser to a less dense medium, and the angle of incidence is greater than this critical angle, refraction doesn't occur. Instead, all the light reflects back into the denser medium, a phenomenon known as total internal reflection. This principle is the backbone of fiber optics, the technology that makes high-speed internet possible. So what have we learned today? Refraction is the bending of light as it passes from one medium to another, and it's responsible for a variety of everyday phenomena. It follows specific laws, and understanding it introduces us to terms like angle of incidence, angle of refraction, refractive index, critical angle, and total internal reflection. It's a concept that's not just central to physics, but also to our daily lives, reminding us that science is everywhere, even in a simple glass of water.